It's working good. But yeah. So, my interest in engineering originated from my parents and, like she had just stated, the installation of cars from my father. As a kid, there would be stories and funny stories about how I wouldn't be able to make complete sentences. I would blab, I would blah, blah. But if you took me outside, I would be able to name all the cars parked along the street. Over the years, as I was growing up, my father and I would keep instilling each other with the fascination of cars and even attend car shows. So after hearing this, a lot of people would ask me, why not go into automotive engineering? Why manufacturing instead? Which is something that I can answer with one sentence. Over my years of growing up, my fascination went from cars themselves to how each of the parts worked with one another in a seamless fashion. To further push that point, my interest went from cars as an individual topic to all types of machinery, which completes the full circle as to why I am in the manufacturing engineering department. In my first 2 years of learning the various methods of manufacturing engineering at Farmingdale State College, with wonderful help and support from the TRIO and the C-STEP programs, I have been able to adequately learn and use different softwares and techniques such as AutoCAD, Autodesk Inventor, and SolidWorks. These very difficult softwares and the courses that I was taking in my first 2 years were extremely challenging, but these challenges came with a slight hint of entertainment and excitement. The thought that I would be able to take the knowledge and tools that I was learning every day and be able to apply it to the real world at some point in time kept me motivated to do my best and strive for the top. This opportunity came to my doorstep when I was accepted and able to intern at my first internship. Coincidentally enough, I did not know that people from this internship would be here. With the help from the C-STEP and RAM programs, I was accepted into the SERP program at Brookhaven National Laboratories, aka BNL for short. There's gonna be a lot of acronyms and names and things like that, so I'm just gonna shorten it for you guys and myself as well. It was here at BNL, under the mentorship of Nicholas Yonyak, that I was able to fully use my imagination and the skills that I had learned in my first 2 years with an engineer in the field to help develop and analyze a design for a very important component of something called the Deep Underground Neutrino Experiment, also known as DUNE. These things in DUNE, it's a very difficult and intricate system, so please stick with me as I explain it to you. As you can see, I hope you don't mind if I turn around, there is a neutrino-producing cannon-like machine located near a particle detector, aka the NEAR detector, located under the Fermi National Accelerator Laboratory, also known as Fermilab, located in Batavia, Illinois. From Illinois, the machine would shoot something called neutrinos 800 miles underground to a second underground particle detector, aka the FAR detector, the near and far being the location in respect to the cannon that I just mentioned. And in this second detector, the neutrinos would hit a liquid argon substance, that's a chemical, where the neutrinos would interact with it, change, and then from there, the scientists in that existing lab section right there would be able to analyze the neutrinos on how they operate by themselves and once they change. This second detector and the existing labs are under the Sanford Underground Research Facility, also known as SURF. So, what did I have to do with this huge project? It's actually a lot simpler than you might think. I was in charge of developing something called the cable trays. Jayden, what are cable trays? Let me explain. In the second detector, stick with me, after all of these neutrinos interact with the argon and such, in order for the scientists to actually study these particles, there are special cables inside of the second detector that is needed for the detectors to notice the neutrinos, for them to attract the neutrinos to the side of the detectors so that the scientists can read the readings and get the information. However, this is a very taxing and difficult operation. So these cables need a good support system so that they don't break under pressure or become too cold. That's where I come in. I was in charge of taking care of the cable rungs, like the cable tray top, that's how it was at the top, and the wire ropes. Those wire ropes would be connected to cable rungs. So we have cable trays connected by wire ropes with cable rungs. Think of the cable rung as any stepping platform to a typical ladder. You understand? Great. So what I needed to do was create the cable rung, where you can see there are 13 in total. There were 4 total iterations where I had to make one up in AutoCAD and Inventor, the 2 softwares that I mentioned before. Bring them to my mentor to see if it worked out. If it did, we would go back to the lab, configure some readings, see what will work. If it didn't, back to square one, design, analyze, test. Design, analyze, test. So for these tests, there were multiple conditions that needed to be considered, such as boundary conditions, the finite element analysis, also known as FEA, which I will explain later, displacement conditions, allowable stresses, hardware. Basically, long story short, I needed to create something and make sure that it was strong and sturdy enough to withstand the heavy task that I was going to put on it in this experiment. So, like I just mentioned, look at, this is nice, this is wonderful, we love this. The boundary conditions mentioned before, as you can see, the A and B, those are the boundary conditions. Those arrows on top is the load of the liquid argon and the cables that would be put onto it. So these were chosen to assist the simulation of the cable rung under applied loads present in the real world. Think of it as breaking a pencil, if you would look up to me. The boundary conditions would be your 2 hands. One here, one here. The load, as you twist it, would be coming from under it, and then it would break. So the finite element analysis, AKA the FEA, was exactly that. I put the 2 boundary conditions in the holes, and I needed to know how much stress can this pencil take before it breaks. That's all it is. As you can see and zoomed in here, that's where most of the stress would be, which is a good thing. This is the displacement readings, which basically means from the start of where it is to the end of where it is based on the load, that's how much it would move. Usually, red is not good, but since this is displacement, this is perfectly fine. More readings that I needed to consider were the allowable stresses. To keep this very short and simple, if you look at the table, the maximum FEA von Mises stress, don't worry about that, just look at the numbers. The stuff on the left, 5.7 and 39.7, that's what I got. I needed those to be under the 7.8 and the 5.3 and the 53.8. So since the ones that I got were lower than the ones that were allowed, we love that. That's great. The same logic could be applied to the hardware capacity check. You see the eye bolts and the shackles, those are real life tools that would be hypothetically used for my project. Same thought, the capacity is what we don't want to go over. The load is what I got. Since the load is under the capacity, we love that. That's exactly what we need. So basically, everything is within acceptable readings and the displacement levels are satisfactory. So, what did I learn from this internship? I learned new methods. I learned how to apply myself in different areas. Came back to college, things started getting a little easier. The material was looking familiar. I was getting more acclimated, which is something that I'm actually very grateful for. Case in point, my senior project right now, a bunch of different configurations, code, but my partner and I, since I'm a 2-man project, we're doing it very well. To summarize everything that I've been doing all this time, as you've just seen, things have been challenging. There have been trial and tribulations, but through my determination, my support system that I also love, and my internship with my mentors, I've been able to spearhead it, I've been able to do what I gotta do, and I've been able to improve. So as my final message to you, I'm telling you right now, personally, I fully plan to keep spearheading and keep doing what I'm doing, and keep getting better, and keep learning and acquiring more knowledge. Because if I do that, I'll better myself and maybe even better the world around me, which is what I really want to do at the end of the day. So I appreciate Dylan and all the staff members who were a part of the reason why I'm standing on this green dot. I appreciate my support system for keeping me afloat and keeping my head up. And I appreciate all of you sitting in these relatively comfortable chairs listening to me talk for 10 minutes. Thank you.